Hi everyone, we are going to now move further in Module 20 to 20.2. We're going to do parts A and B, and this portion we're going to kind of do them at the same time. And what we're going to be looking at is that correlation coefficient, and we will be using Excel for most of this, hence the reason I have Excel up. And that's a good thing because it's going to do all the grunt work for us. So first of all, just some information about that correlation coefficient. And what it is, first of all, the correlation coefficient measures how strong and the direction in which this linear relationship between the two variables is. So if you were to look over here on my graph that I have, you can see that we do have a upward positive slope going on with our straight line, and it does look to be very strong. And we will find that when we do calculate this correlation coefficient, we will notice that. And we'll be doing that one a little bit later. First of all, the symbols that we use, and we've used a lot of symbols in this class for a bunch of different things. First of all, if we were talking about the population coefficient, correlation coefficient, we use this funny looking P. It is a Greek letter, and it is our rho. It is a P. It kind of looks like a P, but it's like the Greek R. So we've used mu for our mean, sigma for our standard deviation. Now we're going to be using rho for this population correlation coefficient. If we're doing a sample, we've always used letters. And the letter we're going to use for our sample correlation coefficient is the letter R. Get to hear my cat making noise in the background. I'm sorry about that. There's some properties for this correlation coefficient. First of all, there are a few of them. It has no units. So it doesn't have any units that depend on the units of what our measurements are. So for our temperatures, if these were in degrees Fahrenheit and these are in dollars, the correlation coefficient is completely unitless. The values will come out to be somewhere between -1 and a +1. So if we get values outside that range, we made some sort of mistake. And we will be letting Excel do all the work, so we shouldn't be making any mistakes. If we were to change our x and y's around, the correlation coefficient does not change at all. So if I switched which ones represented my dependent and independent, it's not going to matter. We'll get that same value, which is what we would want to happen. Because sometimes the dependent and independent parts are interchangeable, like we saw the weight and height. Does our height depend on our weight? Does our weight depend on our height? I don't know. Also, if we change them to different scales, the value will not change. So if we change temperature from Fahrenheit into Celsius, it won't change. If we changed all our dollar amounts or whatever those were measured into euros, this correlation coefficient would not change. And the last property we have is it is very sensitive to outliers. So if we do have an outlier, we do want to be very careful because it can cause this correlation coefficient to be stronger than it is or not as strong as it should be. So we kind of look at those kind of situations in more detail if you were going into the statistical world. Okay, the formula for this beautiful thing is an ugly mess. We're never going to calculate it, but I do want you to see it so you appreciate the fact we never have to calculate it. And there it is. Okay, so to do this, if you were talking about it, you'd have all your x's and your y's. So you would need a couple of columns. You would need to calculate your x times your y's, and then you would add all those values up. So we would need to take our 60 times this 210, the 70 times the 318. We would also have to add up all our x's. We'd have to add up all our y's. We'd have to square all our x's and add those all up and stick all those things into this beautiful formula, and magically, boom, it would fall out. The nice thing is we do have technology, and we'll be using Excel to find it for us. In this section, what we're going to look at is just kind of looking at our graphs and then reaffirming that yes, it's positive and it's strong or weak or not weak. So we do have a little bit of a scale to kind of help us as to, is it strong, is it mildly strong, is it weak, is it not weak? So the strength of our linear relationship, again, is going to depend on that R value. If it turns out that R is exactly 1, this data will show a perfectly straight line. Everything will be on a straight line going up. This one looks pretty gol darn straight to me. We should see that this is going to be pretty close to 1 because they are almost on a perfectly straight line. If it's between 0.8 and up to that 1, we're going to say it has a strong positive going up linear relationship. If it's between 0.5 and 0.79, we're going to say moderate. 0.1 to 0.49, it's going to be a weak. If we're very small, like the 0.01 to 0.09, we've got a very weak. Okay? If we do get a 0, that means we have no linear relationship. We could have a curve of some sort, but we would have no linear relationship. If we get R values to be negative, first of all, that's going to indicate we're going to be going downward, so a negative trend. And again, kind of backing up the other way, a negative 0.01 to negative 0.09, very weak, and then weak, moderate negative relationship, strong negative, I should have put the word linear in there. And then if we got that negative 1, we would see that perfect negative straight line. Okay, I'm going to keep this kind of up here so we can kind of see, and we'll kind of use that as a guide as I kind of go through some of these examples. And I'll show you how we actually calculate that linear correlation coefficient. So it isn't difficult to do when we have Excel. Without Excel, we have to go through that long, ugly formula. I don't know why people would do that. Okay. Our module does show you another method of getting the correlation coefficient a little bit more detailed. I think the one I show you is a lot easier because it's right there at our fingertips. So first of all, what I've done, and I will also post this Excel spreadsheet along with the notes on the video link in our Blackboard course. So I have typed in the data, and I did a real quick scatter plot. I showed you in the last video how to do a scatter plot, so we can see that yes, we have a positive, looks very strong, so we should be seeing some really large positive numbers, very close to 1. To calculate our correlation coefficient, what I'm going to do is grab an empty cell, and in the cell next to it I will actually type in the word correlation coefficient, kind of abbreviate it for us so that we know what we're doing. And we have used Excel a little bit in the past, and we've used this little FX key, and that's where we're going to be getting this correlation coefficient. So I'm going to click on that, and again it brings up all of these different choices. I do want to make sure I am in the statistical list because that's where all of our statistical formulas are found. And we're going to go down in the list, and we're going to come across this CORREL, and that is the one that's going to calculate our correlation coefficient for us. So I'm going to grab that, and I'm going to hit OK. You can type in this function too if you wanted to just type it in. A lot of times I search for it because I can sometimes don't remember what it needs. So what this thing needs is our x values and our y values. So our x values are going to go in this spot here. So I've got my cursor, you can see the little blinking thing there, which means I'm in that spot. It's wanting my x's. I'm going to go to my thing and grab my x values. And you'll see that they went from A2 to A11. And you can kind of double check A2, A11. A tells you what column you're in. Then I'm going to put my cursor in the next row. That's where it wants my y values. And there they are. Okay, it also kind of tells you what it wants down here. So I'll show you that when we do it again. I'm going to hit OK. And you see that we do get this 0.988909. Again, yes, very close to 1 because these were very close to being linear. Okay, let's do another example. So I'm just going to go into sheet 2 where I have put some more data. So this is going to be the cost, and these happen to be cost of running shoes. I did get most of these examples right from our module. And then the rating that they were given. And as you look at this, we see it's pretty scattered. So what I can see also maybe a slight downward possibly trend, maybe an outlier, not 100% sure, but I don't see any curves here. So since there's not a real strong curve appearance, I can go ahead and calculate that correlation coefficient. So again, I'm going to grab an empty cell, going to go up into my function, go down to make, it is already in statistical because that's where I've been, CORREL, hit OK. See in array 1 it wants those values, so those are my x values. Then I'm going to get my y values, and I'm going to hit OK. So again, now we get this negative 0.42. According to our list, we have a weak negative, which is kind of what I suspected looking at this slightly negative piece. So very weak negative. All right, this one, I see a definite curve. Okay, so on this one, we should not go any further. Do not go further. Because I see a curve, I don't want to put a straight line in this because I see a stronger curve than I would a straight line. So if I were going to do some statistical analysis on it, I would try to fit a curve to this rather than a straight line to this. And the correlation coefficient measures straight line strength. All right, I have a couple more just so we can see them. Here I have, again, widely scattered data. Possibly an upward-ish trend, but I don't see a curve. So therefore, I will go and calculate that correlation coefficient. And the more practice we see this, the better. So again, CORREL. If I went too far, there you are. Okay. My x values and my y values. And I get a 0.303. So 0.3 weak positive. Again, the positive tells me we've got an upward trend, negative lower trend. I might want to look at this point up here because maybe that guy is an outlier, which is making it less positive. I don't know. We'd have to throw it out to see. All right, last example I have is here. And this one is actually your age and your dairy ounces. And I see a nice negative piece going on here. I would say moderately negative, but we'll see for sure. Again, correlation coefficient kind of is a better way of judging than I am because it is a statistical measure. So we'll go and grab that and see where we fall. And we come up with a negative 7.4. So yes, moderately negative. And again, strong, they would have been a little bit more tightly compact. We will, in the next video or the next sections, actually look and see, statistically speaking, because these are kind of just words, but statistically speaking, is there a straight line that fits there? Or should we not really look at our straight line? And we will actually be doing some hypotheses testing to see, do we have a straight line or don't we have a straight line? And that will be in our next video. So I will see you there. And hopefully you're enjoying all these videos and learning something. But again, email me if you do have questions. Thank you.